Good morning, good evening, good afternoon, and good night. My name is Jeremy Andoni Gunawan. I am from the class Numerical Method 1, and today I'm going to present about my final assignment, which was given by Mr. Dai, our lecturer. Um, I have explained about the synopsis of my final assignment below in the video here, and you can watch it on the before. So in that video, I explained about the abstract of my project, the introduction, the objective, and the model description. So to summarize, I will tell you in a bit about my project. So my project is about optimizing the battery capacity of the delivery drones. So what it means is drones nowadays are used as delivery purposes. Big companies like Amazon, Alibaba, and such have use drones as delivery devices that can um, deliver your packages. They're ordered online um, with the speed up to 80 kilometers per hour and carrying 2.27 kilograms of packages. So the challenge is optimizing the battery. So the more the battery capacity, the more um, deliveries it could deliver in one go. So to find the most optimal battery capacity, I created this project um, to find the most capable battery. Um, Nowadays, drones are using lithium-ion batteries, which is why it seems to be a problem. It usually only lasts 30 minutes. So by using this project, we can find, hopefully, it can find the most optimal battery capacity percentage by considering the drone speed, the drone package carrying it's carrying, um, and the travel distance maximum. So um, this project aims at the finding the most optimal battery capacity for delivery drones. There are some constants that we can assume, like the work hours per individual drone per day, which is 6 hours, and the mass of the drone, which is 10 kilograms, and the power efficiency of the electrical motors and the propeller, which is 0.75 and or 75%, the standard, and the lift to drag ratio of a drone is 36.48, and the area of coverage 56.25 pi. This is in kilometers. So there are um, a few things to cover. For the formula D, which is the total distance of a multiple demand points that are visited by a single vehicle per tour, uh, there is this formula, which is A, B, and C, and K. K is the constant, as in 0.16, considering the size of the surface area, which is this 56.25, and ABC is the constants in a 100 by 100 square catchment. So after that, we can find the T, which is the total time spent by an individual drone completing a tour. D plus 2L divided by V times the number of packages. So the difference between D and L, D is total distance of multiple demand points, while L is the um, line distance, which means L is more of a distance from the depot or from the drone housing to the specific point where it can deliver multiple deliveries. So that is L. That's why it's 2L, because it goes back and forth from it going out and then going back home. So we can find the battery capacity here by this formula, and then there are some constraints, which is the number of packages cannot exceed the total mass, and the total distance cannot exceed the area of coverage, and the total time cannot exceed the work hours per day of the single drone. So this is the coding. We can import this numpy and import math. We can input the assumptions, which we have tell you before. Drone hour per day, drone mass, power transfer efficiency, lift to drag ratio, and coverage area of a drone. And then next we can input the speed we want. So we can input the speed, we can input the maximum travel distance, and we can input the number of packages per delivery. So if this works, that means it's viable, and if this doesn't work, that means the combination of these three is not viable. So we can also put in the variables, and we can put in some formulas like the mass of the package is number of packages times 0.5, which means we assume that every package is weighted as 0.5 kilograms. So the total of the mass is equals to drone plus the package. This is the formula before, which is dk a plus n a times this is multiplied. There's a typo here. Npack, number of packages, plus b times this also, there's a multiply here, the numerical log of number of packages plus c, and then there's the time, which is d plus 2l divided by v speed times the number of packages. There's also the battery capacity, which is shown here, number of packages plus total mass times speed times time divided by 370 times the power transfer efficiency and the ratio, lift to drop ratio, times 100%, and the max distance is d plus 2l, which is this here. So the equations, this is the same because the max distance is d plus 2l. That means we can change it, the equation, into a number of packages can exceed the m total, the 2/3 of the m total, and the max distance is here, and the max distance over speed cannot exceed the work hour. So this is the printed result. So for this case, I will enter the average or the standard drone speed, which is 50 kilometers per hour, and the maximum travel distance usually is 15 kilometers, has a radius of 15 kilometers, and then the number of packages for delivery I will use 2. So by implementing this code, I will get these results, which is 273.253 optimal battery capacity for drone delivery. So you need 273.53% of the battery capacity for the drone. So these are obtained by these data, which is the ones we input, which is 50, 15, and 11. So the conclusion is, by telling the code the project a certain speed, a certain package weight, and a certain travel distance, or we can find the optimal battery capacity percentage needed. So in this case, by delivering the drone at 50 kilometers per hour and then covering the area at 15 kilometer radius, and also delivering 2 packages, it needs 273.53% of the battery capacity. And a lot of improvements could be implemented into this project, like adding more constraints to make it more accurate. Let's say the drone flying height, drone conditions, drone rules of flying, like it has to be under 400 or 500 feet in Indonesia, and it could lead to very expensive items, or expensive battery or propeller or parts of the drone that could be expensive. But maybe finding a cost variable, by adding a cost variable into this project, could make it more cost efficient and economy friendly. For we can count how much is the payment for one delivery of drone per day, per delivery. So by finding that, we can make it more cost efficient, and the big companies could make it so that it will be as cheap as possible but still optimal. So this is the file for my project, and this is the references. So thank you for listening. This is my final assignment. Goodbye.